Thanks so much for coming. This morning I want to solve a mystery with you, how the zebra got its stripes. And I call it a mystery because no one in this room has seen that happen. And we have no written records. If someone watched it happen, they either didn't write it down or their records were lost. So it's a mystery. And what I want to do this morning is walk you through some of the clues that we have to try to answer it. Now, in one sense, we already have the answer to how the zebra got its stripes. As best as we can tell, zebras are born without stripes. This is a horse embryo, but I think it serves as a useful analogy. This is a 10-day-old horse embryo. You can't see any head, no hooves, no tail, just looks like a formless blob. But this is a horse, but it becomes the form that we recognize slowly over time. This is day 30. This is day 65. You can now see the hooves, the tail, the head, what looks like eyes there, day 85. By birth, the zebra has stripes. So in one sense, the answer to how the zebra got its stripes is simple. Well, from its mother, of course. How that happens is still a matter of debate among developmental biologists, but of course it raises the question, is the zebra white with black stripes, or is it black with white stripes? Now, the zebra's skin is black. So you might say, well, the answer is obvious. Must be black with white stripes. But then there are these mutants that exist from time to time in the wild, like this. How do you explain that? Is that black pigment gone awry? Is that white pigment that failed to be deposited? What's going on in creatures like this? Then there's the blonde zebra. How do you explain this guy? Black with white stripes or white with black stripes? And then here's a third individual to consider, actually a group of individuals to consider. You have zebras that scientists are trying to breed the stripes off of. They're trying to get rid of them. They've had some success, and as the stripes disappear, what appears underneath is a tan-colored coat. So think about that. What's the zebra then actually? White with black or black with white? There's a bigger mystery I want to answer. That's the developmental biology mystery. The bigger mystery is, what about the first zebra? So you got the zebra that gets its stripes from its mother, from its parents, and those parents get their stripes from their parents, from their parents, from their parents, and eventually get back to the beginning. So what did the first zebra look like? From whom did it get its stripes? How did it get its stripes? Was there an unstriped ancestor in the beginning? And again, none of us have seen that. If there are written records of this, they've been lost. So it's a mystery. So we want to walk through the indirect clues to try to get to that answer. So let's start with the obvious. Where do zebras live in the wild? They live in zoos, obviously, but in the wild, where do we find them? Anyone know? Say it aloud if you know it. Africa. Why do they exist in Africa? And here's their distribution in sub-Saharan Africa. Why there? Why in the savannas of Africa? Is it because the environment provides the best shelter? Is it because this is the only place on earth where they can flourish and survive? That was one of the points that Darwin debated, and it's a point that scientists are debating to this day. They still don't know what the function of these stripes are. It seems to be an obvious camouflage, but it could also function in thermoregulation, transfer of heat. Africa's hot. Could shield the zebra in some way from biting of flies. There's all sorts of hypotheses they're still debating. But let's work with camouflage because that seems to be obvious. It seems to shield it quite well. It exists in Africa, it survives quite well, but Africa is not the only place with savannas. Northern India has savannas where zebras could theoretically thrive. Northern Australia has savannas where they could do so as well. Brazil has not only rainforests but savannas, and even though the Midwestern United States is not technically a savanna, you have to have a certain amount of rainfall to be classified as such, it has grasslands where it seems like zebras could survive just fine there too. Why only Africa? Zebras aren't the only species that have one unique location. Think of the camel. Again, it fits its desert environment quite well. And by the way, the wild camel exists only in Central Asia. The dromedary is a domestic version. You find that in North Africa. You can find what's called a wild population in Australia, but that was really domestic dromedaries brought in and they somehow escaped, I guess. So there's wild, so to speak, in Australia, but they're not native. The camel is native only to the deserts of Central Asia. And it, again, survives quite well. And if you know much about camels, they have humps that store fat. They have membranes on their eyes that keep out the sand, double set of eyelashes. They can shut their nostrils. They have foot pads that can expand in the sand. They fit their environment extremely well. So is it only the Central Asian desert where they survive well? Well, we mentioned the domestic ones exist in North Africa. There's deserts there. There's deserts in Australia, deserts in southwestern Africa, Namibia, deserts in South America, deserts in southwestern United States. But no wild camels in any of these locations. Why? What about the orangutan, found only in Southeast Asia? It's got hands that are kind of like feet for swinging through the trees. It subsists on a diet that has a lot of fruit in it. But it could swing through the trees and consume lots of fruit in Central Africa and the rainforest there, or in the Amazon of South America. Why are orangutans only present in Indonesia? Well, one of the biggest clues comes not from the mainland, but from islands. The Hawaiian Islands have mammals on them, indigenous mammals, mammals that are native to Hawaii. 9 mammal species are native to Hawaii. 4 are shown here. This is a fairly diverse group. The killer whale, I think that's a pygmy sperm whale. You've got a seal, you've got a bat. What do these 4 species have in common besides the fact that they exist in Hawaii and that they're mammals? It's a pretty diverse group of creatures. Think of it this way. What type of mammal is missing from this group? And this is representative of the 9 total species. So there's a limited amount of mammals, and they have something in common. And there's a type of mammal that's missing. One that has legs. So something that can get there by walking. You don't find any mammals like bears or deer, camels in Hawaii because they can't walk there. But if you can fly there, like the bat can, or swim there, like the whales, seals, sea lions can, you can make it. That's generally true then. This is what Darwin and his colleague or collaborator or competitor, depending on your perspective, Alfred Russel Wallace observed in 1859. This is Alfred Russel Wallace's map of the biogeographic zones of the world. What does that mean? So Wallace observed that there are regions of the world that have species there and nowhere else, and they tend to fall in groups. So notice in yellow there, that's basically the region in which zebras live, and then there are other species that are native only there, the African elephant, certain species of hyenas, the list goes on. There are sub-Saharan species that exist in sub-Saharan Africa and nowhere else. The Palearctic region is basically North Africa, Europe, and most of Asia, Central and Far East Asia. There are species that exist there and only there. Now, not all of Asia is part of that region. Southeast Asia, which is what Wallace called the Oriental region, is a separate one. That's where the orangutan lived. The Australian region, you can think of the mammals that exist there, the marsupials, kangaroos, so forth, separate region. North and South America each have their own separate region. Species that are native there but nowhere else. What Wallace observed is that these seem to be defined by barriers to migration. So just like we observed in the Hawaiian Islands, the species that are native are those that can get there. Those that are absent are those that can't. You've got barriers to migration all across this map. So what defines the sub-Saharan African region? Well, the Sahara, obviously. That's a pretty big barrier to migration, kind of hard to cross. Well, what about this Palearctic region? Well, if you look at most of Asia, there are very few barriers to migration. If you're in North Africa, yeah, it may be hard to get across the Mediterranean, but you can just eventually walk through the Middle East all the way around and back up into Europe. You can get there by walking. Might take a while, but you can get there. Why is Southeast Asia cut off from the rest? Well, you've got these very tall barriers called the Himalayas that make it difficult to get from North Central Asia to Southeast Asia. Himalayas are a significant barrier to migration. What about Australia? Well, there's significant water barriers between the Asian mainland and Australia. Australia is basically one big island. So there's a barrier to migration. North and South America are cut off from what we'd call the Old World being Europe, Asia, Australia, Africa, by oceans. Atlantic on one side, Pacific on the other. And North and South America are separated, you can see there, by that little narrow stretch of land, the Isthmus of Panama. So you can get from North America to South America, but there's this little narrow bottleneck of land that makes it challenging. So the Sahara forms a barrier to migration. With respect to zebras, this begins to make a coherent picture. Why are zebras only in sub-Saharan Africa? Well, maybe it has something to do with migration rather than with the environment. Well, we talked about the Hawaiian Islands as a key clue. There are some islands that violate what we just discussed. There's an African island in particular, Madagascar. Can anyone think of a native species to Madagascar? And if you've watched some of the Disney movies, something might come to mind quickly. The lemur. The lemur does not fly. And it's a land creature. So how can you have a lemur on an island? For that matter, there's 100 species of primates. Lemur is classified as a primate. There are 100 species of primates. Primates are terrestrial. How do you get 100 of these on an island? Madagascar is not the only exception. The Galapagos are as well. They're off the coast of South America. Darwin visited these islands. A number of evolutionists have been doing studies over the years on these islands. There are 4 species of rodents. They walk, they're terrestrial. But they're really not the most amazing species. It's the giant tortoise of the Galapagos that weighs several hundred pounds. That's really the most interesting exception. How did this guy get there? He doesn't fly, obviously. Maybe he could swim. He's a reptile. But what do we do with these islands? You've got 3 we've discussed, the Hawaiian, the Galapagos, they're off South America, and Madagascar. Well, let's measure the distance visually to each of these mainland. So you got Hawaii, that's a significant distance from North America. The Galapagos are closer to South America than Hawaii is to North America, and Madagascar is fairly close to Africa. Well, think about it this way. Can mammals swim? Some can. And if you're a mammal and you just happen to jump in the water and you're off the coast of East Africa, you might make it to Madagascar. Many might not, but many might. And if you're off the coast of South America, you hop into the water, you might make it to the Galapagos. If you're off the coast of North America, you hop into the water, you probably won't make it to Hawaii. So statistics seem to explain these exceptions to the rule. There's another factor to consider, though, and let's think about Australia in particular. Lots of marsupials there, the kangaroo being the most iconic marsupial. How do you get from Asia across all these islands down to the island of Australia? Well, here's where not the land, but the oceans help us understand this better. If you look at the ocean depth, so in this slide, dark blue is deep ocean bottom, light blue is shallower ocean bottom. You can see all around Australia is fairly light blue, connecting you all the way up to Papua New Guinea, and Southeast Asia is mostly connected to Indonesia and such is connected to Southeast Asia via this continental shelf. You can see the far east coast of Russia connected to Alaska by some light blue. You can see the island of Great Britain, the British Isles, connected to Europe via a lot of light blue. That means the oceans are fairly shallow there. You can see Florida connected to the Caribbean islands by light blue. Both creationists and evolutionists would say there was an ice age in times past. Evolutionists would say there were many. Creationists would say there were one. Creationists would say it followed the flood, and that the flood provides the only conditions, really, that could allow this to occur, that the evolutionists are still struggling for an explanation. During an ice age, what happens? You've got water that evaporates, goes into clouds, eventually precipitates onto the land in the form of snow, packs into ice. This moves water from the oceans to the land, which means the ocean levels will drop. And if the ocean levels drop, land that is today underwater might become exposed. So during an ice age, you could nearly connect all of the major continents, except maybe Antarctica, together, forming one big landmass that terrestrial mammals could migrate across. So, putting all these pieces together, the distribution, the geography of creatures around the globe today seems to be explained by migration. Barriers to migration seem to define regions where there's groups of indigenous creatures. And when you think about statistics and historical events, you can create a plausible scenario in which these creatures could migrate. One island I forgot to mention, Japan. You can see it's also connected to the Asian mainland via the shallow shelf. So back to zebras. We can imagine that, yes, the Sahara is a significant barrier to migration, but perchance, sometime in the past, a zebra might have walked across it and gotten to Africa. That seems to make sense. But there's a problem. There isn't just one species of zebra, there's three. What I'm showing you here is the plains zebra. It's got fairly thick stripes that reach all the way around its belly. This is the mountain zebra. It's got thinner stripes that do not reach all the way around its belly. And if you've grown up in the area and have been to the Cincinnati Zoo in times past, they had this species of zebra, the imperial or the royal zebra, that's got the densest stripes, and they again don't reach all the way around its belly. Now, these are separate species. Plains zebras reproduce plain zebras. They reproduce zebras that have thick stripes that go all the way around the belly. Mountain zebras reproduce mountain zebras. They have that little dewlap there on its neck. The imperial zebra reproduces imperial zebras, offspring that have dense stripes that do not reach all the way around its belly. So how do we explain this? They're all sub-Saharan African. We could invoke three separate migrations that just happen to get across the Sahara. That might explain why zebras are in sub-Saharan Africa. But it does not explain why none of the zebra species got out. If you're going to invoke some sort of chance event to explain how they got in, well, it seems statistically equally plausible that some might have then turned around and also walked back out. Why don't we find any elsewhere? Let's think about terrestrial creatures again, but not mammals. Let's think about birds. Here are three species of flightless birds. So they're like mammals. They can't fly to where they want to go. They're not going to swim. They've got to walk. The ostrich in black there is African. Those two gray flightless birds are rheas, and they're South American. So applying what we've just learned to this question, how do these flightless birds get to their respective locations? We can imagine, maybe in times past, the ostrich happened to get across the Sahara and didn't get back out. These rheas may have, in times past, when there was an ice age, walked across that land bridge between Russia and North America, gotten across the Isthmus of Panama, down into South America, and that's where they exist today. But here's something Darwin observed. Why is it that the two species in closest geographic proximity, the two rheas, are also the most similar in terms of their appearance? If this is a chance event, why didn't it just so happen that the ostrich in one of the rheas went to South America and the other rhea went to Africa? Why is it that the two rheas that look the most alike are also the closest in terms of physical distance? Darwin knew very little about genetics, but he had a family tree, and he could have looked at his family tree and made some profound observations. You can look at your own family tree. Look at your kids. They look like you, but they aren't carbon copies of you. Something's inherited that says similar, but something gets mixed up that says different. This is what Darwin called descent with modification. So on that principle, Darwin said, this makes more sense. What if we say there was one migration to Africa, one migration to South America, and that this principle of descent with modification produced a new rhea species? This would explain why the species in closest geographic proximity also look the most alike. So going back to zebras, we can explain this pattern by invoking a single migration across the Sahara and subsequent diversification, speciation, to produce a total of 3 zebra species. This makes sense of the statistics, it makes sense of how similar they are, and it also implies that zebras got their stripes from somewhere else. That's our first clue. Zebras got their stripes elsewhere. The ancestor of zebras didn't originate in Africa, came from elsewhere and migrated in. Well, there's a second clue we want to look at, and it comes not from geography, but from the other species in the family to which zebras belong. So Linnaeus invented our modern classification system. We use a genus name and a species name. So these 3 zebras, they all belong to the same genus. The Latin term is equus. The plain zebra is equus, or the mountain zebra is Equus zebra. That's the one species that Linnaeus named. The imperial zebra is Equus greve, and the plain zebra is Equus quagga. There's 4 other species within the same family to which these zebra species belong. So in the Linnaean system, you have a species, you have a genus category, a more broader category is family. There's 7 total species in the family to which zebras belong. The family's name is Equidae. 7 wild species. You can see on your right a partially striped species. That's the African wild ass, Equus africanus. The 2 central species are the Asian wild asses, and the one on the far left, the tan one, is the Przewalski's horse. You can find that at the Cincinnati Zoo. And what's interesting is, if you take a good look at the back of its leg, sometimes you can find a stripe. I emailed one of the people there, and they said, yeah, those are primitive markings. That's what they call them. 7 species. Now, what I want to do now is take the first 2 chapters of Darwin's book and make the argument that he made in the context of zebras. What's interesting is, what Darwin opened his book with was not transitional forms. It was not anatomical comparisons. It was not embryological comparisons. It was not a discussion of natural selection. It was a discussion of breeds. This isn't part of the popular debate, but it's a really interesting argument. So let's walk through it. This is what Darwin said. He said, take a good look at all the variety in species. We have it here on the screen. You can see there's stripes, there's black and white colors, there's tan colors, there's some gray. And that's about it. They all have 4 legs. There's a lot of similarity here. The point is, look at the variety. Then Darwin said, let's compare that to breeds, the domestic versions of some of these creatures. So here's some of the variety in horse breeds. Notice all the different colors: black, white, tan, gray. You've got different patterns: polka dots, splotchiness, solid colors, spotted color, or mottled colors. And the variety goes on. There's all sorts of variety in horse breeds. I'm just showing you some of it here. Small ones, large ones. Here's 2 next to each other, so you can see the amount of variety. And it's not just horses, it's donkeys that have variety: long-haired, short-haired, gray, tan, white. So Darwin's challenge to his readers was this: is there more variety here, or here, and here, and here, and here? So in Darwin's day, the creationists erroneously thought that God created individual species, fixed and unchanging, and in their current geographic locations. We'll talk about why that's wrong in a little later. So Darwin said, you believe that all of this variety in donkeys came from a common ancestor. And they would have to agree with that. Why? Because we humans were responsible for producing them. We watched it happen. All the variety in horse breeds, we produced it. We watched it happen. So they would have to concede, yes, all of this variety came from a common ancestor. And let's put some numbers on this. Anyone know how many breeds today exist of horses and donkeys combined? Wild guesses. Hundreds? 873. That's that second row there. In the family Equidae, the domestic versions we have 873 breeds, just 7 species in the wild. That pattern holds true in other families in which we have domesticated versions. Bovidae has cattle, sheep. It's a family that has cattle, sheep, antelope, so forth. 3,000 plus breeds. Only 135 species in the wild. Pigs, 669 breeds. In the wild, which includes warthogs, wild boars, and so forth, just 18 species. Rabbits, 231 breeds, 62 species. Camels, 106 breeds, and llamas, 3 species. There's a huge excess of breeds over species. So this was Darwin's challenge to his opponents. He said, okay, you agree that all of this variety goes back to a common ancestor. One ancestor can produce all of this. Those same people would have turned around and said, well, this little bit of variety, those go by separate ancestors. Darwin said, that's not logically consistent. If you're going to say all of this comes from a common ancestor, then you have to say this goes back not to separate ancestors, but back to a common ancestor. It's a powerful argument. It's also a limited argument. Anyone know what the closest living relatives of the equids are? So we've got the 7 species of equids, zebras to horses to donkeys, that we can say are related. Evolutionists say their relatives go beyond the horse family. Any guesses? They belong, so if we go up the Linnaean classification system, species, genus, family, order, they belong to the order Perissodactyla, that includes mammals that have an odd number of toes. Which families might this include? There's 2 of them. Camels is a good guess. Hippos is closer. rhinos and tapirs? Can all the variety in horse breeds bridge the gap between equids and rhinos? Can all the variety in donkey breeds bridge the gap between equids and tapirs? There's too many differences. There's a big gap here. So Darwin's argument applied across the spectrum says that equids have a common ancestor, but that ancestry has a limit and it doesn't go back to the rhinos and tapirs. Now the evolutionists try to bridge this gap with fossils, transitional forms. There's a problem here though, and this is basically all you have to work with. We've been looking at horse breeds and comparing their coat colors and hair color and so forth. You don't have that information with fossils. So the type of argument we're using runs into trouble when you have bones. Because all you have is bones, the artist can take great liberty trying to reconstruct it. Now, I want to dwell on this point briefly. I want to take a sidestep here and talk about this. Darwin made this point, and it's used with as much force, if not more force and vigor today as back then. So what if someone one day discovered a creature that looked like it was half rhino, half horse? Would that tell us the ancestry goes back further? I want to cover very quickly here the nature of science and what you need to think about for this potential future scenario. And I'm going to use a silly example, but it has a powerful point. So here's the silly analogy to understand how science works and how we understand transitional forms and zebra ancestry. Let's say there's a couple that's been happily married for less than a year. They're enjoying all the pleasures of marriage, companionship, love. But as the months pass, their relationship begins to grow cold. The spark is kind of missing. And the wife begins to wonder what's going on with her husband. So she observes his behavior more closely to try to figure out what's wrong and how they can restore their relationship. She notices that he comes home from work later and later each day. Well, this is disappointing. She wanted to spend time with him. So she presses him. What are you doing? Why are you home so late? And he's non-committal and avoids answering the question. So now she's even more suspicious. So she begins to watch not only his time, but his money. She looks through his wallet for his receipts. What's he spending his money on, not just his time. And she noticed receipts for chocolate and flowers and jewelry. So now she's really concerned, and she confronts him about this. Look at all these receipts. What are you doing? What are you spending all this on? Again, he avoids the question, goes to bed. The next morning, wakes up. She can smell he has a lot of cologne on. She says, well, now I'm gonna catch him. So waits for him to walk out the door, shuts it, he drives off to work. She calls up the rental car place, rents a car because she doesn't want to be noticed, drives off to his work right around 4:30, waits for work to close, and just as she suspected, he leaves work at 5 o'clock, exactly when he's supposed to. Now, I gave part of this talk in Colombia, South America. The Colombian power grid is unlike the North American power grid, and at this point, the power went out. And my translator looked at me and said, it appears that there's a man in the audience who doesn't want you to finish your story. The power came back on, and I finished it. So he drives off from work. She follows close behind him. And then he begins to make a few familiar turns, left, right, left, and before she knows it, he's pulled into the driveway of their house. And then she remembers. Today is their 1-year anniversary, and he's been working late to buy gifts for his wife to surprise her on today's anniversary. And now she's sitting in a rental car, embarrassed, having to walk through the door in shame. How could she have avoided this embarrassing scenario? Well, she applied the process of inductive reasoning erroneously. That's the same method of reasoning we use in science. We observe a pattern of things, we try to infer a general principle. Well, she observed a pattern, very suspicious behavior. She knew that men who behave suspiciously are often cheating on their wives. So she jumped to the conclusion he must be cheating on her. Well, the biggest danger in inductive reasoning is because it's inductive and you're trying to infer something, you have to eliminate competing explanations before you reach your conclusion. That was her problem. Yes, do husbands who behave suspiciously often cheat on their wives? But there is a competing explanation. Husbands who plot romance for their wives to surprise them on their anniversary also behave suspiciously. And she never eliminated that competing explanation. That principle applies to science as much as it does to this little story I told you. Well, what if someone found a transitional form that's halfway between rhinos and horses? What would that imply? Well, the first question we need to ask scientifically is, what would the competing explanation be? Genesis 1 doesn't tell us the principles that God used when he designed creatures, but it does tell us that he made man in his own image. In the image of God, he made man, which tells us that even though we live in a Genesis 3 world where the curse has happened, man is sinning, and some of that image has been marred, if we look at how humans design things, since we're made in the image of God, we might be able to infer and get a little glimpse of how God might have designed things. Well, how do humans design things? Let's take a military analogy. When humans want to design firepower to move quickly through the ocean, they design ships. This works fantastic in the ocean and packs a big punch. You can take it all the way around the world. This thing would do nothing on the land, be pretty useless and be blown up in a war scenario. So what do military engineers do? They design tanks to move firepower on the land. And again, it's very good at what it's designed to do. It packs a big punch, all sorts of terrain. This would sink like a rock in the ocean and be useless. But for the land, it works great. Well, what if you want to move firepower from the ocean to the land or vice versa? Engineers design transitional forms. Vehicles that blend the features of two very different vehicles. What is this? A ship? A tank? It's got treads like a tank, but it works quite well in the water and moves from the water to the land. It's an amphibious assault vehicle. This fits, in one sense, what evolutionists often define transitional forms as. And this is just one example. You can think of many more. Again, if you want to move firepower through the water, you design ships. Through the air, you design planes. And if you want to combine the two, you design an aircraft carrier. And we've designed all sorts of ingenious ways to move from land or floating land on water to the air. Really ingenious ways. Here's a fire combating device. This guy, you might think this guy lands on a runway, parks and hooks up to a hose. Well, it can load its water tanks even better than that by landing directly on the water, filling them up, and then taking off again. So the bottom line is, if someone discovered a transitional form between zebras and rhinos, it would tell us nothing about the origins debate. Because transitional forms by themselves are equally explicable by creation and evolution. And the only way the evolutionists could use it in their favor was to first eliminate the creationist explanation. They'd have to find some other way to do it. Transitional forms would not do it. So, how are we going to determine if zebras and rhinos have a common ancestor? The only way scientists could possibly do this is by looking at the only direct record of a species' ancestry. The only direct scientific record of our ancestry is in that molecule that's passed on in sperm and egg. What's passed on in sperm and egg? A fossil? A little bone? It's a molecule called DNA. The only way we can directly interrogate anyone's ancestry scientifically, if we have no written record, is through DNA. Now, how much DNA did Darwin know in 1859? How many DNA sequences were known? How much genetic information was known in 1859? 0. How much DNA information was known in 1953, nearly 100 years later? 0. That's when the structure I just showed you was first discovered. The first DNA sequences were not discovered until 1968. In 1982, we had less than 1,000 DNA sequences in our public databases. It really wasn't until 1997 that we had a million DNA sequences. Why is that significant? Because there's over 2 million documented species alive on this planet today. Darwin wrote a book on the origin of species, tried to answer their ancestry, nearly 150 years before we'd have the data to directly investigate it. So Darwin took a gigantic scientific risk over 100 years in red. Another way of saying this is, the question about the origin of species is one we can finally answer now. We haven't been able to before then. Well, what is the DNA sequence of these 7 species? That wasn't discovered effectively until 2014. That paper was published. That's step 1. There are other genetic measurements we need to make, so this is an active area of research. For now, we know there's a big gap between zebras, I should say between equids and supposedly their closest living evolutionary relatives. Now, let me just prove to you and close one little loophole here. How do we know that zebras and asses and horses do have a common ancestor, if we're only at step 1 of genetics? Well, let's talk about transitional forms, but let's not talk about bones. Let's talk about things that were once living for which we have pictures. In 1859, this creature was still living. It's now extinct. It's the quagga. It might have been classified as a separate species back then. Today, many scientists call it a subspecies. Why a subspecies? Because they're trying to recreate it. Those images I showed you earlier are part of an ongoing project to recreate the quagga, Notice that it has stripes basically just on its neck and face. They're trying to remove the stripes from this plain zebra by picking and choosing particular individuals to breed off those stripes, and they're having tremendous success. In fact, they've done it. Actually, that's a fib. That is one of the Asian wild ass species. But could you know the difference if I hadn't told you? So you're convinced now that zebras and the asses and horses have a common ancestor. We'll take a trip to our petting zoo if you get a chance. You'll find something like this. This isn't a zebra. This is a cross between a zebra and a horse, a zorse. It has stripes. This is a cross between a zebra and a donkey that has stripes on its legs. And notice how similar it is, at one level, to a wild species, the African wild ass. Stripes only on its legs, gray coat. This has stripes only on its legs, gray coat. Now, they're not exact duplicates, and I don't expect them to be. I'm not saying that this species arose by some breeding between a zebra and a donkey. But hopefully what you can see is we have sufficient evidence to say that the 7 living species of equids have a common ancestor. And we'll learn even more once we have the genetic sequence. So that's our second observation about how the zebra got its stripes. They got their stripes from elsewhere. The 3 species of zebras have a common ancestor who lived outside of Africa, and in fact that ancestry extends further to the other living members of the equid family, but that's where it seems to stop. Well, let me take Darwin's argument one step further. Darwin didn't spend too much time in his book talking about the time when species originated. He didn't derive it. Those concepts were worked out before him. The creationist model was rejected in terms of time by the scientific community before him, and so he just adopted it for his purposes and said, yeah, species take millions of years to form. Well, let's take those first 2 chapters of Darwin's book and apply them not to the question of ancestry, but to the question of time. How long did it take these species to form? So I'm going to take Darwin's argument and reverse it on him. Darwin would say millions of years. So we're going to compare the variety again between species and breeds, but we're going to think about the time question. So Darwin says millions of years for this. This little bit of variety, millions of years. How long would evolutionists say it took for all this variety in breeds to form? This variety, and this variety, and this variety, and this variety, and this variety. And again, we can put numbers on this. How long did evolutionists say it took 873 breeds of horses and donkeys to form? 3,000 plus species of cattle, sheep, and goats. 669 breeds of pigs. How long did that take? Well, think about it step by step here. We humans were responsible for producing them, which means we have to go to the evolutionary timescale. Again, I'm not endorsing it, I'm just stepping into their model to see where it leads. When did intelligent humans exist in the evolutionary timescale? Millions of years ago? The evolutionists say that the ancestor to humans and that the ancestor to chimpanzees split 6 to 13 million years ago. The ancestor to humans gave rise to proto-humans, and it wasn't, Homo sapiens sapiens didn't evolve until 200,000 years ago in Africa. That's what the evolutionists say. Which means we have an upper limit. The evolutionists would say all the breeds must have originated in 200,000 years or less, by definition, because intelligent humans haven't been around to breed them until recently. But you know what's interesting? If you look at the evolutionary literature, they don't say that breeds originated 200,000 years ago. This is what they say. Again, they say these species originated over the process of millions of years. Breeds, all of this variety, all of this variety, all of this variety, all of this variety, took 12,000 years or less. So is that consistent? Is it consistent, Darwin and your evolutionary descendants, to say that this little bit of variety took millions of years, but all of this variety and this and this and this happened in the blink of an eye, so to speak? Now, I'm not endorsing the evolutionary timescale. I'm saying even if we step into the evolutionary model, there is a logical contradiction. You can't say on one hand that species take millions of years to form, but all these breeds are just a few thousand years. Now let me think about some objections. What might the evolutionists say? They might say, well, that's not a fair comparison. Breeds have humans involved. The reason it went so fast is because intelligent human beings have been applying themselves to this process. And in the wild, there's no humans, so it takes longer. Okay, let's work with that. But let's apply it back to Darwin's argument. Darwin said all this variety in breeds has a common ancestor, therefore species in the wild do as well. Well, we might say, no, we can't use that analogy because humans are involved in the breeding process. Do you see what's going on? Any objection the evolutionists used to my time argument applies equally well to Darwin's ancestry argument. So if you want to throw out the time argument, you may as well throw out the first 2 chapters of Darwin's book, which brings them back to square one in terms of trying to refute the creationist model. The only way they can refute this is by throwing out Darwin. I don't think they can. There are other problems with their 12,000-year model. There are certain assumptions that are erroneous, and so if you question those assumptions, you can bring that timescale right in line with the biblical one, 6,000 years, 4,500 years, or less. My point is, data from Darwin himself points to conclusion number 3, that zebras arose recently. 3 clues to the origin of zebra stripes. They came from somewhere else, outside of Africa. They have a common ancestor with other equids, horses and asses, and this happened recently. Isn't it amazing that we made all these observations from the scriptures? We didn't make observations from the scriptures. These are all arguments from Darwin's own work. It just so happens that everything I've told you, coming from Darwin's pen or coming from the application of Darwin's pen, fits exactly what the scripture says. And if you've been to other talks at this conference, or if you're just here for the day, you look through the museum, and maybe you're going to go to some other talks, you might have been familiar with this concept of kinds. So here's where the creationists of 1859 went astray. The Bible doesn't talk about species. Genesis 1 through 11 is written in Hebrew. And the Hebrew doesn't talk about species. It uses the word mean, M-I-N, which many English Bibles translate as kind. Unfortunately, the New King James talks about, in Genesis 7, uses the word species, but it's an erroneous translation. I'll explain it in a moment. So what is a mean? To make a long story short, mean is not species, not even genus, so species, genus. It's probably the level of family, which fits exactly what we've just inferred scientifically. Apply this to the flood account. God tells Noah in Genesis 6, bring 2 of every land-dependent, air-breathing kind on board the ark, not species. So Noah did not take 2 plain zebras, 2 mountain zebras, 2 imperial zebras, two of each of the species of asses, and 2 Przewalski's horses on board the ark. He took 2 members of the equid kind. And from these 2 have descended the different species that we see today, all in the process of 4,500 years. So the scriptures are okay with new species forming. The Bible also anchors this on a specific geography that says the ark landed in the mountains of Ararat. It landed, creatures spread out, they migrated. This is the distribution of equid species today. As we discussed, the zebra species, if you can see my pointer here, are sub-Saharan African. The African wild ass is in Ethiopia and Eritrea. The Asian wild asses, as their name implies, are in Central Asia, and the Przewalski's horse is extinct in the wild, but it used to be also in China. It fits this distribution from the ark. What the Bible forbids, so it permits new species to form, it forbids change of one kind into another, which in shorthand version, would be change of one family into another, as a general rule of thumb. Now let me prove this to you real fast. How do we know this is true? How do we know that one kind cannot change into another kind? Well, let's say that kinds could become other kinds. Whales are mammals. These 3 families all belong to the mammal class. If whales could become other creatures, there is no need to bring anything on board the ark. The whales, or the fish for that matter, survive the flood in the ocean. After the flood's done, they evolve onto the land and produce every creature that we see today. The point of the flood, the point of the ark is there is none if kinds can change into other kinds. The fact that you needed an ark and you needed to bring 2 of every kind shows that there's limits to change. So everything we've just inferred about the origin of zebra stripes fits exactly what the scripture says, and what's amazing is when you apply Darwin and take him to his logical conclusion, it fits. The evolutionists would vigorously disagree with what I said, but they're not walking through his arguments carefully. They're making the wrong assumptions. They're not taking it to its full conclusion. Now, I still haven't told you exactly how the zebra got its stripes, or what its ancestor was like. Notice, actually this will serve the purpose. In this family, in this kind, you have striped creatures, the 3 zebra species, and that African wild ass has stripes on its legs, and you have unstriped creatures. Now, that Asian wild ass has a stripe down its back. We mentioned the primitive markings on the Przewalski's horse in the back of its legs. But you got something heavily striped and basically no striped. So what was the ancestor like? Well, genetics will hold the answer, and that's something I'm going to discuss on Saturday if you come back, or you can find me afterwards.